All right, doing this for my own sanity, but in case you're listening, someone was talking about basically, I mean, it really should be known as relativistic wave function. So basically, it's relativity and wave particle duality, but it's a relativistic wave function. And this was actually created not too long ago, maybe like almost 30 years ago, 25 years ago. And I actually have it like a picture of the equations like in my background. Those are the equations. Those are the relativistic wave function equations. And this is these I would say, I mean I'm not totally sure, but if you have a static state Big Bang, say your static state Big Bang has been around for some time, they do I mean, I have been confused by static state Big Bang and cosmic inflation. So I think they're saying that they're kind of going with uh, cosmic inflation for a long time, and then they were able to create a static state Big Bang. That seems like more realistically what it would be instead of they just now created this cosmic inflation theory because it's cosmic inflation is something totally non-proportional to entropy, and I know there's entropics where there's sort of like human hope or human like humans' necessity to innovate. I think is probably a good like recall of what actual entropics are. But then you have entropy, and entropy is just talking about how there is degradation in the universe. So that gets confusing. Not so much in terms of cosmic inflation, because what you're really talking about. I mean, it should really, I guess, be called cosmic deflation, because you really have energy deflating before you. You don't really have. I mean, you have something like the sun, okay, that is getting bigger and bigger, and basically more toxic to mammals because it's going to be radiating more. But then you also have um, this idea that everything's cooling in the universe, and also everything is expanding. To me, everything expanding in the universe to me is a very dangerous idea because if you actually uh, thought about it, it's not really that precise. I mean, it's not really that realistic, especially if you just think in terms of your galaxy, if you think in terms of your solar system, if you think in terms of your planet, if you think in terms of anything that is uh, in space time or that is more relativistic, like the galaxy, you probably come to you probably try to understand how an expanding universe isn't really all that possible. I mean, it's not possible to wrap your head around. It shouldn't be. So it's not. So therefore, it's not really theoretically possible. Like it's not humanly possible to say, um, entering our extinction, what our extinction would really be like. I mean, we can't really say for certain. Okay, there has to be some uncertainty again to like uh, I guess, extract like any innovation out of it. But again, that doesn't really deal with an anthropic theory, something that deals with human innovation. Unless, yeah, you want to say like we're going to be more adaptable to the radiation. And I mean, this is the anthropic idea is that we would be more adaptable to radiation because we know that our planet is going to slowly warm. It's getting into this faint young sun paradox, and I guess it's almost judiciously stated that our sun was a lot smaller, and our sun, like 4 billion, 5 billion years ago, our sun was a lot smaller, and essentially, like it's the sun's size. The fact that the sun was able to grow I think by 30, like it grew by 30% maybe in 4 billion years, like 4.5 5 billion years. The sun grew essentially 30%, I believe. Um, but what I'm trying to say is that it only had 70% of its actual, Jesus Christ, excuse me, of its actual energy for us right now. So the paradox, so the faint young sun paradox, is that it was very faint and it was very young, and it's a paradox that it was able to produce enough energy at 70% of its capacity now to be able to heat up the glaciers. Okay, I wasn't even really aware that all planets like have like like glaciers are possible and all that stuff, but it's like Mercury. If Mercury's too close, then everything's just on fire. Venus, it's too far away, so everything's gaseous. Everything's still way too hot. It's too gaseous. Mercury's just like a fireball. Uh, Mars is way too cold, but then you have Earth, which is essentially the perfect temperature. But you also have like the moon. The moon was supposed to hit like Earth after 500 million years, and there was just like a ton of meteorites and all this stuff because it was just constantly dragging in meteorites or meteoroids and all those things. Meteorites were hitting and all over the place, and then finally there was like some cohesion between like the moon and Earth, and that's essentially like going from Hadean. So it's going from like Hadean to essentially the Archeon age. So you have like the Hadean. I don't know why it's called Hadean, but I thought it was called something else like the Hal. Well, actually, I think we're in the Halcyon age, or the Halcyon era, and there was like the Hadean era where the moon, I think, was where the moon had destructed the planet, and then they slowly came into equilibrium, and that was around the time that the sun was big enough, 80%, 90% of its, well, I guess 80% or something, 70%, 80%, 75%, and that's how much. So it had enough energy to be able to actually create water, so actually melt some of those glaciers. But again, Mars is way too cold, and they're saying that they've seen water on Mars, or frozen water, or sort of erosion from water, like the Grand Canyon, just erosion from water. And so yeah, there's that type of there's definitely that type of thing going on. Um, but yeah, it's it's interesting. So yeah, you just go from the Hadean to the Archeon age, and the Archeon age was when the prokaryotes. So the prokaryotes are what precede life, and then the eukaryotes are what actually are able to carry multicellular life. But then yeah, you have the Archeon age, and the Archeon age is when this would have eventually enveloped. So yeah, I guess that was 2 billion years ago. But yeah, I think they do say that there was I think they are calling water or something biological life, which is disturbing. Yeah, so then we just get into the Fermi paradox and how there are livable planets, but the livable planets, they don't have, they're either too hot or too cold. They're either too much like Venus or too much like Earth, or sorry, too much like Venus or too much like Mars. And yeah, they just don't, they are not compatible with evolution. And I really don't believe that there is any other form of evolution. There's mammals, there's reptiles, uh, like flying reptiles and like birds, and then there's amphibians and things like that. But I mean, we're talking about mammals here if we're talking about our species. And yeah, just there'd be no more inclination of this alien species or whatever that somehow is able to evolve like on a more radiated planet like Venus or something, like a planet just with so much radiation. Because that's really the only idea that we're battling, since it is this. So it's more of a evolution video, but it just this oxidation process. I mean, and then we're talking about like an extinction debt. So there's like the 9 planetary boundaries, and the 9 planetary boundaries are very mammalian, very uh, Homo sapien, and it's just talking about how we've essentially fucked up biodiversity. Um, but we have this extinction debt, and extinction debt talks about how um, we essentially have fucked up our diversity, um, but it's the last thing basically on our agenda. So, like I was talking about how um, things could have been really chaotic between mammals once mammals were able to evolve uh, from sea life, and they were able to contest uh, herbivorous or carnivorous reptiles like the dinosaurs. You're just thinking, well, they should have been really small. Like our ancestors, our mammalian ancestors essentially should have been really small because they were able to basically hide out and do those types of, like they were basically able to hide really well or go underground even, like dig holes or whatever they had to do, like tunnel holes. And so I'm just saying this whole diversification process that is what mammals are going through. I guess wildlife and human animals or non-human animals, uh, the diversification process happens when there is actual extinction going on. So extinction is essentially supposed to force the diversification. So uh, extinction happens like these between these 9 planetary boundaries or through these extinction debts, and these uh, are the things that are basically the difference between uh, like just natural selection, like natural selection again being uh, a a part of the species going to like a very small group of species going to essentially another group of species, and then they start interbreeding with that species. Essentially, like you have like mixed people, like half black, half white. That's like essentially like mixed people, okay? And then so that's like a form of like just a natural selection, because yeah, there is a lot of extinction going on. I mean, you're talking about, I mean, we're not really talking about extinction here, but we're talking about actual problems like a debt, okay? Like an extinction debt is a pretty good word. So the diversification happens, and that improves the overall genus, like the overall mammalian Homo sapien, I guess, okay? Um, But essentially, the extinction debt ends with diversification. So that's pretty clear. Um, so it's not saying that diversification is going to like save our species. It's just saying that the diversification is what is going to end up happening so long as we keep procreating. As long as we have disrupted not disrupted, but I mean, we don't like we're just migrating. We're just constantly migrating. So if you migrated somewhere long enough, the idea is that yeah, eventually like there's going to be, I don't know, just this extinction day. I mean, it's actually getting pretty confusing, more confusing than I thought. Um, so yeah, the sun was at 70%, but yeah, and then you just and then so the relativistic wave equations, what I have in my background, like they're called Diracian equations. They're very much like kinetic energy. Yeah, I just don't like mentioning these people's names because they just seem like insane traitors or bought out people or something. I mean, I don't know. I mean, it's hard to call somebody a traitor in America because it's like um somehow you have to always justify the fact that this country was built on genocide and slavery. And if like anything could really sound worse than that, it's probably not that bad. So it's just like, well, if nobody's like, I don't know, if nobody's like pushing the red button on procreation, then like what is the point of like what realistically is the point of the argument? So that always happens to me. So yeah, I don't need to mention the guy's name again, but relativistic wave function is, from what I saw, essentially just this these kinetic energy equations, because these kinetic energy equations, and when I did look at it, there were it was just a lot of permittivity, a lot of beta duality, wave particle duality, a whole lot of theta, whether it's lambda or theta. These all seem to be interchangeable with frequency, wave, and all of this stuff that is supposed to be sort of constant. And so long, and essentially, there could have been 150 equations that, or 500 equations, or 1,000 equations that essentially said, no, we live in there's no separation in our universe. We are connected through the living force, the kinetic energy, and there is no separation. So that's my real difficulty with everything. I'm not really, I don't plan on going back from that. This whole idea that there should be I don't know, just idiosyncrasy or something, or meaning, like there has to be some meaning. I guess in the universe, or some meaning in, because it's like, it seems like every time you accept the universe, you have to deny evolution, and every time you accept evolution, you have to deny the universe of its ability to create more evolution. Because the fact of the matter is that if we don't think that we are sort of like an evolutionary unique species, in the sense that, yeah, it can't be, it's like it was the perfect temperature to melt the water, or it was the perfect temperature to start the Archeon prokaryotic age or era. um I mean, even the blue marble, I mean, like, if I guess the blue marble is kind of like disingenuous to the idea that we shouldn't, you know, well, I guess it's disingenuous to the idea that we should think that we are special, like we have some natural compass, like we have some real compass, essentially with our sentience, but just in terms of our evolution, like that's what these no separation theories do. That it's like kinetic energy, relativistic wave function that was created, 250 or Uh, yeah, essentially 300 years later, you have like this relativistic wave function, and spaceships and all this stuff are landing on Mars. You have you have the alien paradox, the Fermi paradox, where you're going to, you have to evaluate all the planets in the universe, and oh, well, this, just needs this planet just needs to be 100 degrees more hot, 100 degrees hotter, and then it'd have perfect life, or it'd be the perfect, it has to be like I don't know about template, but it has to be the perfect, more or less like ingredients to be able to restart evolution. So I'm not even talking about like you know what some people would think are miracles, or these fake miracles. I'm just talking about a single cellular organism, which is a prokaryote, and the prokaryote somehow was able to generate itself into a eukaryote, and humans can't even allow a prokaryotic single cell organism, is what I'm trying to say, to be able to survive on its own and transform itself into a multicellular organism, which is essentially a eukaryote. Correct me if I'm wrong, but I'm saying that's what humans are incapable of doing. Okay, so if you're telling me, like, they have all of this data on everything, but they can't even do the recreation of evolution, then whatever. I mean, they don't have anything. To me, they don't have anything, especially if they're only creating multicellular, or especially if they're only using multicellular eukaryotic bacteria and just letting those expand. And somehow they want the eukaryotic bacteria to be able to uh, pass on its single cellular organisms, and they want to be able to study that or something, or they just want to. I know all they're doing is trying to get this single cell organism off the ground, but they can't do it. They can't get it to evolve to the next level. It dies right away. So they just, again, use these multicellular eukaryotic cells. So they can't recreate it. They can't do that. It's unfortunate, but I mean, bygones be bygones. Like they're like, that's evolution. That's evolutionary biology, and then you have, I guess just I guess evolutionary biology is kind of doing the same. Well, biology is like a lot different than I'd say, uh, sort of like geographical, demographical, not anthropod. What am I trying to say? Anthropological scientists, and that people studying extinction. So that would be like a little bit different, in my opinion. I don't think evolutionary biologists are trying to do anything other than, just recreate the single cellular phenomenon, which they can't even do, but they have all this data. So, I mean, that doesn't yell aliens to me. It just yells, okay, like that's the answer. Like, let's just get this over with. But, of course, their answer is, well, we need to be able to grow, hearts and livers, and we need to be able to grow all these organs. You know, we just need to become like the transplant masters. And that's really sad. So, yeah. There's one more thing that I wanted to mention, but I don't quite remember what I was trying to remember. Um, Something I heard, like just well, yeah, oh yeah, the cryogenics. I mean, I had no idea. I thought cryogenics was actually like cloning. So I mean, they're nowhere near cloning. Okay, all they can clone is marijuana plants. All they can clone is like plants for that matter. But so all they really have the ability to do is clone. Okay, they're just sorry, cloning plants, but they don't have. Even if they wanted the ability to clone, they can't do that. They don't have this transplant mechanism to be able to turn like single cellular organisms into something tougher. And even if that did it, they still, I mean, they can't even recreate single cellular organisms, let alone will they be able to let alone will they be able to do something about like actually cloning humans or putting human consciousness into a clone of themselves or all that bullshit. And those are anthropics. Okay, that's like this accordance that humans need to be. I mean, I agree with anthropics. Like, I think the anti-procreation movement is anthropic in that it is, sort of trying to be altruistic. But then if you have, it's being altruistic to me, or veganism's being altruistic to me. That doesn't mean it's being like it's altruistic for other people because they see anthropics and other measures. Just I mean the necessity for humans to be innovative. So humans need to be innovative somehow, but they don't know how to do it. And the unfortunate like aspect to that is yes, like there is a lot of, I would say, just way too much optimism about the future. I mean, it's unrealistic optimism. So if you can't help the animals in cages or the humans in cages or um the animals or humans with no home, like why do you think that you're going to be able to help future generations live to be 300, 400, 500 years old or something crazy like that? So I mean that stuff is the idiosyncratic stuff, and that's the stuff like I'm really not worried. And it's just the idiosyncratic stuff is just really faint, um, in terms of you don't know people's placement anymore, whether they're trying to earn money and things like that, versus like their actual meaning. So are people actually saying this because like they're firm believers that in 300 years we're going to metamorph into some beautiful species or what? Like, so I mean that's the sort of like the clog, like it's like this clot or clog, I should say. And so nobody's really talking about that aspect of like I guess the absolute, I don't know, just like this absolute interpretation of the universe is not like it's a non sequitur. It doesn't make a difference. We are not separate. Like there is no separation. I have a really serious problem with that, and it's like dark. It's Descartian, at his worst. It's Descartes at his worst, and it's every spiritual guru person, the wooist, like now. Um, I mean, there is some line that people won't cross, I don't think, but the whole separation thing is totally. I mean, whoever like understands physics, who understands, like whoever has heard the word quark, they would understand this degree that there needs to be a separation. And my point is whether it's anthropic, like whether it's human innovation to try to find like this necessity for life in the universe, or it's just like pure, I guess, moral will to want to understand more about the universe and understand more about cryogenics, or time travel. I don't care, like wormholes, whatever. uh this is totally, this is there, like there is no like there can't be any exception to the physical rule, or like the laws of actual physics. And maybe it's the fact that they are using laws of physics that are completely, like, I mean, just for example, like kinetic energy or relativistic wave function. If these were actual laws, which I don't think they are, I haven't done too much research, but yeah, it'd break everything that would be like physical in the universe, and um, then yeah, everybody would be jumping on board with that stuff. But we know that we're not capable. I mean, we don't even have any clear data on the cosmic soup, kinetic energy, or whatever the muons or the gluons or the quarks or whatever those things are that are actually um, actually enveloping like the separation between the photons and all that stuff. Like those photons, they get those photons that are measured, whether it's barometrically. I guess it's like kind of like barometrically, like sort of with hydrogen and oxygen. So those whatever separation is happening there, yeah, it's like it's happening because there's like a real reason, but we can never know what that reason is, essentially. Let alone, can we even recreate the single cell organism evolving into a multicellular organism? Like they just can't survive on their own. So how did the single cell envelop into a multicellular organism? So people jump on board with expansive universe, or there's evolution out there, the Fermi Paradox, and all of these things are very entropic. They're a necessity for human innovation. It's a necessity for human innovation, and it's very distracting because they completely become idiosyncratic, meaning like they're very obscure and all that. So there's not really any meaning. There becomes a total lack of trust, unity, meaning, anything that actually means anything in like a community setting, in terms of the physics. And yeah, so it's really sad, and that's what I'm gonna continue to talk about.